Good evening, dear students. Now I want to discuss aldol condensation. When alpha hydrogen containing aldehyde or ketone involved in nucleophilic addition reaction in the presence of mild base, beta hydroxy aldehyde or ketone is formed. On heating this compound, water eliminated to form alpha beta unsaturated aldehyde or ketone is formed. Clear? So this is aldol condensation. So, which are involved in aldol condensation? Alpha hydrogen containing aldehyde or ketone. So, alpha hydrogen containing aldehydes or ketones. Example, estaldehyde. Estaldehyde. This is functional group. Functional group adjacent carbon alpha. So, estaldehyde involved in aldol condensation. Now, propanaldehyde. It is involved in aldol condensation. Propanaldehyde. This is functional group, adjacent carbon alpha, beta. So two alpha hydrogens are there. It is also involved in aldol condensation, propanaldehyde. Now, acetone. This is the ketone. Acetone. This is the ketone. This is functional group, adjacent carbon alpha, alpha. This is also adjacent carbon alpha. 6 alpha hydrogens are there. It is also involved in aldol condensation. So these are the molecules can participate in aldol condensation reaction. Even cyclohexanone, this is the functional group, adjacent carbon alpha. This is also adjacent carbon alpha. Here two alpha hydrogens are there, here two alpha hydrogens are there. So it is also involved in aldol condensation reaction, cyclohexanone. So these are the molecules can participate in aldol condensation reaction. Now example, when 2 moles estaldehyde involved in aldol condensation reaction, here we can use dilute base. So dilute NaOH and followed by heating. Now this is the functional group, adjacent carbon alpha. How many alpha hydrogens are there? 3 alpha hydrogens are there, estaldehyde. How many alpha hydrogens are there? 3 alpha hydrogens. So it can participate in aldol condensation. Then which product is formed? CH3, CH double bond CH, single bond C double bond OH. This compound is formed. This is the functional group. Adjacent carbon alpha. Next adjacent carbon beta. So it is also named as alpha beta unsaturated aldehyde. Clear? So now this is the functional group. Carbon 1, 2, 3, 4. What is the IUPAC name? Total 4 carbon atoms. Bute. Double bond starting carbon 2. Butene. And aldehyde is present at all. Butenol. Actually here one no need to mention because always aldehyde exists at terminal. So simply we can write butenol. Clear? Butenol you can write butenol. Both are correct. Now mechanism. How can you write mechanism? Yes, now I am writing or explaining mechanism. So first one, base can terminate alpha hydrogen. Clear? Base can terminate alpha hydrogen. So OH minus, that is the base. It can terminate alpha hydrogen. That's why carboanion is formed. Which is formed? Carboanion. Carboanion. Now, this carboanion is resonance stabilized. This carboanion is resonance stabilized. So that's why when it is involved in resonancy, then enolate ion is formed. Which is formed? Enolate ion is formed. So you know these are the resonancy forms: carboanion, enolate ion. How can you expect question? Which intermediates are formed in aldol condensation? Carboanion or enolate ion? Both are intermediates. Understood? Why only alpha hydrogen eliminated? Because that carboanion only stabilized by resonancy. Stabilized by resonancy with C double bond. For example, if you terminate beta hydrogen, gamma hydrogen, so beta carboanion, gamma carboanion, they are not resonancy stabilized. Clear? Only which is stabilized? Alpha carboanion. Because that is adjacent to C double bond O group. That is adjacent to C double bond O group. Understood? That is adjacent to C double bond O group. That is the reason. That's why only alpha hydrogen eliminating. Clear? Now, from these two resonancy structures, you can take any one of them. Now you can take carboanion. Here you can take carboanion. This carboanion react with one of the molecule, that is acetaldehyde. So one acetaldehyde already participated. Now another acetaldehyde. This is from one acetaldehyde, you know, carboanion formed. Another acetaldehyde, carboanion is formed. Another acetaldehyde, you can take this one. Can attack like nucleophilic addition mechanism. Now here new carbon-carbon bond is formed. How can we write CH3? CH, it will become O minus. Here new carbon-carbon bond is formed. Now CH2, C single bond, okay, C double bond O H. This is formed. Now protonation takes place. Clear? Protonation here H plus. We can take from water, that H plus added to O minus. Then CH3, CHOH. This CH2 hydrogen we can write like now C double bond OH. This is the functional group, adjacent carbon alpha, next adjacent carbon beta. This is beta hydroxy aldehyde. Now this is aldol addition product. Now if you heat presence of acid or base, that internal hydrogen eliminating, then internal hydrogen hydroxide, water eliminated. So which compound is formed? CH3, CH double bond CH, single bond CHO. This is the product. Clear? This is the product. Alpha beta unsaturated aldehyde. I hope everyone clear. This is the mechanism. Now I am explaining now trick how to write product within 10 seconds. Within 10 seconds. How can you write product? Very simple. From one aldehyde oxygen, another aldehyde alpha hydrogen. Just if you remove, then you can make one double bond, that is final product. Very simple. So now I am explaining trick. Okay. How can you write? How can you write acetaldehyde? Okay. From one acetaldehyde oxygen. Always we have to remove alpha hydrogens. Clear? So now another acetaldehyde you can remove which hydrogen? Alpha. Remember, not beta, not gamma. You have to remove alpha hydrogens. Clear? So now you can remove like. Now what is the product? Very simple. CH3, CH double bond CH, single bond CH. This is the product. Suppose for example, second example, 2 moles propanaldehyde. 2 moles propanaldehyde you can take. CH3, CH2, C double bond O, 2 moles propanaldehyde. Okay, so dilute NaOH and followed by heating. So which product is formed? How can you write easily? Yes, very simple. This is the functional group. Adjacent carbon alpha, beta. Understood? Here what is the product? Below 10 seconds you can easily write product. Below 10 seconds you can write product. How? Listen, from first propanaldehyde, you can remove oxygen. From second propanaldehyde, you have to remove which hydrogens? Alpha hydrogens. So for your convenience, you can write like yes. This is alpha, this is the beta. Okay. From second propanaldehyde, you can write. Now you can remove like water. Understood? Now tell me product. CH3, CH2, CH double bond C, C double bond OH. Here methyl you can write downside. So this is the product. Understood everyone? Now this is the functional group. Adjacent carbon alpha beta unsaturated aldehyde. Clear? Name 1, 2, 3, 4, 5 IUPAC name. Now you can write 2-methyl, okay, 2-methyl pent, parent chain 5 carbons, pent 2-ene 1-all, no need to write all. Aldehyde always existed terminal. So 2-methyl pent 2-ene all. Clear everyone? Yes. Like that you can write any product. Okay. For any reaction you can write easily product. Suppose for example 3. Example 3. 2 moles cyclohexanone. 2 moles cyclohexanone dilute NaOH followed by heating. Which product formed? You can write like, okay, this is the product. Okay, clear? This is the product. Understood? This is the product. Now, trick. Already I told you, from one aldehyde, oxygen, one cyclohexanone, oxygen. From another cyclohexanone, you know, alpha hydrogens. Always we have to remove which hydrogens? Alpha hydrogens, not beta, not gamma. Okay, so any alpha hydrogens you can remove because symmetrical it is. Understood? Now just you can combine. What is the product? This is the cyclohexanone, one cyclohexanone, oxygen. You know, another cyclohexanone, alpha hydrogens. So this is the product. So I hope everyone clear. This is same kind of aldehydes participated. Same kind of aldehydes. Clear. So that's why it is self-aldol condensation reaction. Now crossed aldol condensation reaction. What is the next one? Crossed aldol condensation reaction. Crossed aldol condensation reaction. Crossed aldol means we have to take two different aldehydes. So two different aldehydes. Two different aldehydes are ketones participated. Ketones participated. Two different aldehydes are ketones participated. Among the two, at least one should have, okay, one should have alpha hydrogens. One should have alpha hydrogens. Clear? So two different aldehydes or ketones participated. One should have at least alpha hydrogens. Then they can involved in crossed aldol condensation. Now, example. You can take formaldehyde. Of course, formaldehyde, no alpha carbon. You know, this is the functional group. Functional group adjacent carbon, alpha carbon. No alpha carbon, no alpha hydrogen. Formaldehyde. And another one you can take estaldehyde. Another one you can take estaldehyde. Now base and followed by heat. Now, is it involved in crossed aldol condensation? Yes, because in formaldehyde, no alpha hydrogens, but in acetaldehyde, yes, alpha hydrogens are present. Okay, alpha hydrogens are present. That's why here, from here oxygen, from here hydrogens. Acetaldehyde can give alpha hydrogens. Formaldehyde, no chance. But here condition 1 should have alpha hydrogens, that is enough. Now CH2 double bond CH C double bond OH. 1, 2, 3. What is the name? Prop 2 in 2 in 1 all. Prop 2 in 1 all. Clear everyone? This is the product. This is the crossed aldol condensation. Clear? Now one more example. Example 2. You can take acetaldehyde plus propanaldehyde you can take. Acetaldehyde, propanaldehyde you can take. Understood? Conditions means reagents, dilute NaOH and heat condition. Now, acetaldehyde, alpha carbon and alpha hydrogens are there. Propanaldehyde, yes, alpha hydrogens are there. So both molecules are having alpha hydrogens. That's why here 4 products are formed. 2 self-aldalu, 2 crossed aldalu. So very important, 2 self-aldalu, 2 crossed aldalu. 4 products are formed because both aldehydes having alpha hydrogens. Understood? Now, if you take 2 acetaldehyde molecules, CH3CH, from one acetaldehyde oxygen, another acetaldehyde, alpha hydrogens. Always you have to remove alpha hydrogens. This is obtained from 2 moles acetaldehyde. Now, 2 moles propanaldehyde you can take self-aldol product CH3, CH2, CH from one propanaldehyde oxygen. You know, another propanaldehyde, okay, from another propanaldehyde alpha hydrogens you can remove. Another propanaldehyde alpha hydrogens you can remove. Clear? Another propanaldehyde oxygen you can remove. So this is sulfur from propanaldehyde. Now, from acetaldehyde, oxygen. From propanaldehyde, alpha hydrogens. From propanaldehyde, alpha hydrogens. Understood? From acetaldehyde oxygen, propanaldehyde alpha hydrogens. This is crossed. Crossed. Clear? Now, from propanaldehyde, oxygen. From acetaldehyde, you can remove alpha hydrogen. This is also crossed. So very important. 2 self, 2 crossed. How many products are formed? 4 products are formed. So very simple. Once go through this lecture, definitely you will understand this concept. This is crossed. Now finally, intramolecular aldol condensation. Okay, intramolecular aldol condensation. Intramolecular aldol condensation. Within the same molecule, aldol condensation takes place. That is intramolecular aldol condensation. Within the same molecule, aldol condensation takes place. Understood? Within the same molecule, aldol condensation takes place. Okay, within the same molecule, aldol condensation takes place. Understood? Now, example. You can take this compound, this cyclic compound, cyclic diketone. Okay, cyclic diketone. Here, this is the cyclic diketone. Here, how many alpha carbons are there? 4 symmetrical alpha carbons are there. 4 symmetrical alpha carbons are there. Because it is symmetrical diketone. Symmetrical diketone. Clear or not? Now, when it is involved in aldol condensation, nucleophilic addition mechanism. Now, this is a symmetrical diketone. So, from anywhere you can remove alpha hydrogen. Suppose, for example, from here you can remove alpha hydrogens. Now, from here alpha hydrogens, from here oxygen. Then, what product is formed? Now, you can write like, okay, you can write like, this is double bond O. From here alpha hydrogens removed. Now, yes, this compound is formed. Understood? Functional group adjacent carbon alpha, next carbon beta. So this is alpha beta unsaturated ketone. Clear or not? So this is the 5-membered ring. This is the 7-membered ring. Yes. Now this one we can write like, okay, we can write like. So understood? This is the ketone, here double bond. This is alpha beta unsaturated ketone. So here aldol condensation take place within the same compound. This is intramolecular aldol condensation reaction. Understood everyone? So this is very important lecture. I hope everyone understood how to write product aldol condensation product. Very easy. Always which hydrogens eliminated? Alpha hydrogens. For example, same kind of aldehydes participate. Self, different, crossed. Anyhow, from one aldehyde oxygen, another aldehyde alpha hydrogens you have to remove. Just connect. That is product. Still, so many students are confusing with this concept, but this is very easy concept. Clear? Yes. I hope everyone understood this concept. It is very helpful to you. Thank you. Thank you so much.